Welcome back to the Rust programming series, and today we're going to be talking about functions in Rust. So let's go back to the web page, and you could see over here we have functions, and what a function is basically a prevalent in Rust code. So our prevalent in Rust code, you've already seen one of the most important functions in the language, the main function, right? Which is the entry point of many programs, normally like in other languages like C, C++, right? Java. You've also seen the function keyword, which allows you to declare new functions. Now, Rust code uses snake case as the conventional style for function and variable names, in which all letters are lowercase and underscores separate words. Here's a program that contains an example function definition. So essentially, it's their own convention of how to write, function names as well as some variable names. So you could see over here they have this another function, and then this another function prints another function. So we define a function in Rust by entering fn followed by a function name and a set of parentheses. The curly braces or curly brackets tell the compiler where the function body begins and ends. So essentially we could just write it in our program. So let's go back here. You can see I'm in the folder, and you can see I opened up the variables as well as hello cargo as well as guessing game. So what we're going to do is we're going to go in the variables folder. So I basically say cd and I say variable, and then inside here what we could say is simply code and dot. Now when I bring this in, because now I'm inside of this directory where this is the main.rs file, and we just have a simple function that essentially has a mutable x and then that equals to 5. And then we have the value of x is 5, and then it changes to 6, and then the value of x is 6, right? And if I didn't put this mute thing, this was going to contain an error, and this means, right, it cannot be reassigned. It's immutable. So by default, it's immutable, and we have to make it mutable. So that's why we put mut before it. But now what we have to do is we have to add this thing. So basically, we could create this function. Pretty simple. What I could do is I could remove this, and in here what we could say is print ln exclamation, and then we say hello world, just like that. But when we have another function, we have another function like this, okay? And then over here we're going to create a function fn, another function, okay, another function like that. And then inside here we could just say print ln and then exclamation mark, and then we could just say another function. Okay, so this is essentially the code, and essentially calls that function for us. So we could just essentially go and run it, and I could go back here and I could simply say cargo, and then we have run. Compiling, and then after that we have an issue. It says another function doesn't have a semicolon. What do you mean? So another function, expect a semicolon, found another function. Line number 3, over here we don't have a semicolon. Amazing. So we're going to have that semicolon added over there, save it, and then rerun it. And it should run now. So another function, and then after that, hello world, and then another function being called because it's invoked on the top, right, in the main. So essentially that's how the function would work. These are some of the parameters that we could pass into a function. So we could define functions to have parameters, which are special variables that are part of a function's signature. Now you can see over here that we have a function name main, and we have another function which has a parameter of 5. In the another function, you essentially create a variable that has the value. So I32 is integer 32, 8, 16, 24, 32, 32 bits. Okay, so 4 bytes, and that the value of x is, and then it generally passes the value from here to here, and it's going to say it's 5. So it's going to tell us that it's the value of 5 because it's being passed from here to here. This is an argument, and this is the parameters. Okay, and then over here we have another thing which is print labeled measurement. We have 5, and then we have an h, and then over here you have a unit label colon, and then you tell the type, which is char here. And for that one, which is I32, which is an integer 32, okay, 32 bits integer. So the measurement is, and then you put the value, which is 5, and then h will be the unit. Okay, so print label measure 5h. Statements and expressions. So statements are instructions that are performed some action and do return a value. Expressions return a resultant value. Let's look at some examples. So before going to statements and expressions, I just want to basically demonstrate this purpose here. We'll just have to, just add it right here. It's just going to tell you that there's this 5 and then there's this h. I remember I had this feature which I've added, so it's pretty useful and it tells us whether it's working or not. And it's basically, IntelliSense for Rust, and you could basically get it through the Visual Studio Code extension. And over here you can see the measurement of is 5h, and it just combined both of the things, 5 and the h, and wrote it all together, which is amazing. What is statements and expression? Statements are instructions that perform some action and do not return a value. Okay, they're just some they don't return a value. And expressions evaluate to a resultant value. Let's look at some examples. So we have function main, and let y is equal to 6, and then we have a main function declares containing one statement, and then we have function main let x is equal to let y is equal to 9, and then over here 6. Essentially this is gonna have a problem. So what we can do is, this doesn't return any value, and expressions evaluate to a resultant value. Let's look at some examples. So let keyword is a statement. So creating a variable and assigning a value to it with the let keyword is a statement. So this is a statement. So basically, this is a statement, this entire thing. A main function declaration containing one statement. Great, this is one statement. And then statements do not return values. Therefore, you can't assign a let statement to another variable. As the following code tries to do, you'll get an error. You basically can't assign it to another another variable. So this will give you an error, right? A new scope block created with curly brackets is an expression. A new scope block created with curly brackets is an expression. So let y is equal to x is equal to 3 and x plus 1. This expression, let x is equal to 3, and is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, and it will then not return a value. Keep this in mind as you explore function return values and expressions next. So this is a very cool and interesting in Rust, that you basically don't need to add a semicolon at the end of, go up here. We basically didn't need to include a semicolon here at the end, because if we did, it wasn't going to return that value as 4 to this y. And it would have just evaluate. It was just going to be a regular, statement. But since we didn't add it, it's an expression. Expressions do not include ending semicolons. So pretty fascinating. And functions with return values, we have over here function 5, and then we have returns an integer 32, and then we have 5 over here. So essentially that's the return value. And generally, this is also one case here where we have plus 1, 5, and then we have this, and then essentially it accepts an integer and it returns an integer, x plus 1. So we have to return 6. This is amazing, and that was basically most of our explanation of how this would work. And in this case, it wouldn't, running the code will print the value of 6, but if we place a semicolon at the end of the line containing x plus 1, so over here, because it didn't have one, and that's why it essentially is an expression, right? But if we had an semicolon here, but if we place a semicolon at the end of the line containing, changing it from an expression to a statement, we'll get an error. Compiling this code produces an error as follows, and it will give you this error that says implicitly returns as its body has no tail or so basically it says compiling function mismatch types, something like that. The main error message mismatch types reveals that the core issue with this code the definition of the function +1 says that it will return an I32, but statements don't evaluate to a value, which is expressed by this, the unit type. Therefore, nothing is returned, which contradicts the function definition and results in an error in this output. Rust provides a message to possibly help rectify this issue. It suggests removing the semicolon, which would fix the error. So it also tells you, like, remove the semicolon to return this value. That's amazing. I mean, that is simply amazing. Implicitly returns. And, it just tells you that it returns an I32, but you have the semicolon, and that's just a statement, so you have to remove it so that it could return it. So this is super awesome, and this was basically it with our session on functions. And we're basically learning a lot in Rust. Seems really easy, and I just removed the semicolon. That's why we got 6. So thank you so much for watching it, and stick around for the next one.